This video is creating and analyzing velocity versus time graphs. So again, let's imagine that you have your car. Actually, I can use this time. So let's say you have your car, it's traveling down the road, and this time instead of having a meter stick, you're going to have like a speed gun. And what you're going to be able to do with your speed gun is you're going to record how fast the car is moving. You'll still have your stopwatch here. You're going to measure how fast the car is moving for each second, or at each second. So we're going to go ahead and record the velocity at each second and create a data table again. So let's say it looks like this. Let's say it's 0, 0. It's actually not moving. After 1 second, it's traveling 10 meters per second. At 2, it's traveling 20. Say at 3, it's also traveling 20. At 4, it's 0 or stopped. And then at 5 seconds, let's say it's traveling -10. Remember, a -10 meters per second means that it's actually going backwards or in reverse or in the negative x direction. So why don't you go ahead and press pause again, and we're going to create a time velocity graph. So why don't you go ahead and set that up and then unpause it once you have your graph ready to go. We'll analyze it. Alright, so here's our velocity time graph. So velocity here, notice we do have some positives and negatives this time. And I'm going to now ask you to find the slope again, and also we're going to talk about the meaning of this. So let's find the slope first. Let's go 0 to 2. So again, we're doing delta y over delta x. Our delta y this time is going to be 20. Now this is a velocity, so the units are meters per second, minus 0 meters per second, divided by 2 seconds. 2 seconds minus 0 seconds. Okay, notice we get 10. That's easy enough. What's the units here? Meters per second per second. Okay, so that should be a hint to you. What are we actually finding here? Acceleration. So the slope of a velocity time graph tells us the acceleration. Alright, we'll ask you to think about the meaning here, physical meaning. So what's happening here? We are speeding up, yeah. So in this case, where the physical meaning, we would say, alright, what's happening is we're speeding up. We have this positive acceleration. We're getting faster and faster. We're speeding up in this case. Okay, and you can see from the graph, right? Every second, here we started at 0. After 1 second, we're moving 10 meters per second. After 2 seconds, we're moving 20 meters per second. So we keep getting faster and faster. All right, why don't you go ahead and do it for all of them, please? And think of the physical meaning for all of them also. By the way, let's look at this. Delta y. What is y on our graph? Velocity. So notice what we do when we look at the actual slopes. Delta v, and then what's x? T. So what is delta v over t? Acceleration, right? That's the definition of acceleration. Okay, go ahead and find all the slopes. Alright, so 2 to 3 you should have gotten 0. What's going on what's physical meaning of 2 to 3? What's happening? Okay, constant velocity, yeah, you're moving at a constant velocity. And you do want to be careful. A lot of people will say stopped. Mainly because the last graph we did, that's what happened, we stopped. But are we stopped? How fast are we moving? At 2, we're moving 20. At 3, we're also moving 20. So we're definitely not stopped. You look at the graph, we actually have a velocity. We know what it is. It's 20 for both. Okay, it's a constant velocity. All right, what about 3 to 4? Slowing down. Okay, so 3 to 4, we are slowing down. And what about 4 to 5? Okay, 4 to 5 is tricky because you have this negative here and it's slowing down, and you also have this negative here, but we're now speeding up, yeah. So even though they're both negative numbers, in this case we're slowing down, in this case we're speeding up. How is that possible? Because we changed our direction. In this case, we're slowing down forward. In this case, we're speeding up backward. Okay. In fact, look at the graph. What happens? What happens at 4 seconds? We're at 0 velocity, so we have stopped, right? So our car or whatever it is slowing down, slow, reaches 0, and then what happens? He goes in reverse. So he's actually speeding up backwards in this case. So negative slope, negative slope. So once again, remember, negative slope does not have to mean slowing down. Sometimes slowing down, sometimes speeding up. Okay, let's just continue this. We're speeding up in what direction here? Forward. And we're at a constant velocity in what direction? Forward also. So notice, you can tell we're forward because we have positive velocity. That tells us we're forward, and when we have negative velocity, that tells us we're backwards. So the visual for this problem is our car is going to start at rest. He's going to begin to accelerate, get faster and faster for 2 seconds. So the car is going to start getting faster and faster, reaches a top speed of 20 meters per second. At that point, it's going to maintain that top speed. It's going to then hit the brakes, slow down and stop, and then instantly hit it reverse and start speeding up in the negative direction. Okay, and after 5 seconds, we don't know what's happening. He's, according to the graph, he would just keep getting faster, faster in the backwards direction. Now where he's actually located, you can't tell from what we've done so far, but that will be the subject for the next video.